temperature accelerates a 0.14 kilogram hard ball from rest to 25.5 meters per second in 0.075 seconds. And then there's 3 parts to it, okay? Now, before we start talking about those 3 parts, can you guys tell me what knowns were given in that first sentence? Okay, what are we given as the mass?
0.14 kilograms.
Okay, then you said velocity?
Yep.
Which one? Final, initial, both? Okay, what's the initial?
0.
What's the final?
25.5 meters per second.
Okay, then what else are we given?
Time 3.075 seconds.
You said 0.075 seconds?
Yes.
Awesome. Okay. What does part A want from us?
Yeah.
Okay, so how are we going to solve for work? Is force times distance going to work here?
Yeah.
No. What's the other thing that we know how we can find work? No.
Force times velocity.
No. You guys are going to be using force. You guys, we said that work was also the change in something. What did we say? There we go.
Yeah.
So the final kinetic energy minus the initial kinetic energy. Now, is one of these 0?
Yeah.
Which one?
The initial.
So do you guys think you can plug in 1/2 mass times our final velocity squared and tell us what the work done was?
Mm-hmm. Is it what? Is it like
I got 45.52.
45.52? Yeah.
Yeah, you guys all agree with that?
Mm-hmm.
Awesome. What are the units?
Joules.
Good job. Okay, what does part B want?
Let me see. The pitcher's power output during the pitch.
So it wants,
Power.
how are you going to find its power?
Work divided by time. So you're going to take that work and divide it by our time, right?
Yep, you're going to take that work that you just found and you're going to divide it by our time. What's our time?
0.075.
Yeah.
I got 606.67.
What are the units?
Watts.
Is everybody good on parts A and B? Yes, ma'am.
Because I didn't do the rounded number for the work, then I got 606.9.
Okay, that's fine. That's just because you didn't do the rounded number. That's all it is, you guys. That is it. Not a huge deal. Because I'm pretty sure that if maybe the rounded answer was the one on the test and you got 606.9, because you probably figured out that it was supposed to be that one. Yeah, it'd be okay. All right. All right. What's part C want?
Hold up. It's the power produced more than less than or the same time.
Okay, so basically what it's saying is instead of it taking this long, it takes a number smaller than this, right?
Right.
Okay, so is the power going to be bigger than this, smaller than this, or the same?
Bigger.
Why is it going to be bigger?
Because more work done in less time.
Because more work is done in less
And I
time.
get it.
Yeah. I was trying to figure out how to work that. Like my mind, but my
And if it helps you guys to think about it, to show you what happens, let's say we have 10 joules of work and we did it in 5 seconds. What would our power be?
2.
Okay, now what if we did that same 10 joules of work in 2 seconds?
5.
Do you see how the one that has less time ends up with a bigger number for power?
Yeah.
Awesome. You guys have any questions about 13?
No.
Okay, let's see if anybody in this class can figure out how to suggest to me to do number 15. So it says a sled slides without friction down a small ice-covered hill. If the sled starts from rest at the top of the hill, its speed at the bottom is 7.5 meters per second. So we're given this initial of V naught equals 0, right? And what's VF?
7.5.
Okay. Then part B tells us now we want to know on the second run, the sled is going to start with the speed of 1.5 meters per second, but when it reaches the bottom, we want to know, is the speed going to be 9 meters per second? More than that? 9 seconds. No, I said it right. Oh my gosh, you guys, I'm sorry. It's going to be 9 meters per second, more than that or less than that. And then we want to find the speed of the sled at the bottom. So honestly, we can just jump on to finding the speed because then that'll tell us if it's more or less than, right? So what does it say our initial speed is?
0.
Right? This was the initial case, you guys. This was initially. This is a different one, but it's the same hill. Okay, so we're trying to find the final speed. You're not given mass, you're not given distance, you're not given time.
Right.
So who has a suggestion? You guys can talk to your friends, see if you guys can come up with something.
Wait, what are you trying to do? Oh, no, subtract. So the start to the speed of 1.5 is subtract that to do
Multiply that by the times 1.5.
I don't know.
Okay, wait.
Basically.
Change in is always VF minus V naught.
Because
Yeah.
if you start at
So,
0,
just add them together.
yeah.
1.5
So,
So it'd be 9.
That's probably wrong.
Hey, I like our.
We take
our
7.5 and subtract the 1.
Is the answer 9?
You get 6. There you go. That's what I'm talking
Couldn't we just
What do you think?
say like the mass is 2? And then
If you wanted to assign a mass, you could, but how you do this problem, you end up not needing mass. You don't need mass.
what are it for now?
You don't need mass.
So will be 0.
I think it's not. It's
I
gonna
think
be
it's
bigger than
You would just add
She's gonna hit us, no, it's
Yeah.
0.
1.5.
Yeah, but you guys gotta tell me if you think that, how do we find it?
you.
Well, you first have to subtract your final velocity by your initial.
That's what
The
we
first
were
one. You can do it that way.
That's what I said.
That's
That's
what we
what
were
we
saying.
went wrong.
Trunks?
Does it do with the kinetic energy and potential energy?
It does.
Oh, that's what I was.
I like my way and got.
Wait, hold on, you guys. Trunks is saying something.
Yeah, you just get the equation so you get the velocity final on a single side. Then you just have to just plug in that stuff.
Okay, so then let's think about that. Are you suggesting conservation of energy? Okay, so he's suggesting conservation of energy, which means that we would have mgh naught plus 1/2 mv naught squared is equal to mgh final plus 1/2 mv final squared. Now, do you guys maybe want to do it with this stuff first? Or do you want to try and start with this? What do you want to do?
The first stuff.
The first stuff right here?
Yeah.
Okay. So, let's see what we've got here. If we're starting at the top of the hill, will this be 0? At the top of the hill?
No.
Will this be 0?
Yes.
Will this be 0?
No.
Yes.
Yeah, it's at the bottom of the hill.
Oh,
Is this 0?
Mm-hmm.
No.
No.
No, because there's a final
You guys, think before you speak. Okay.
Wait, why is it MGH?
Because you're at the bottom of the hill, which is at 0. Okay, what can we cancel? The mass, right? It goes away because it's on both sides. What can we solve for that we don't have yet? That might help us with the next thing. Height. Perfect. How do we solve for height? What do we do? Divide by g. Okay? So we're going to be able to find the height now. Do you think the height will be able to help us with
Yes.
the next part?
Yes.
Okay, so how about somebody tells me what the height is when you get there?
Wait, how do you find? Oh, you did the.
Mm-hmm. Does everybody follow what we just did?
Yeah, that makes a lot more sense.
Okay.
Wait, I'm looking for it.
I got 2.87.
Same, that's what I got. What's that one?
What's the?
What would the units be?
Meters.
Okay, does everybody agree with that? Or no? It would be 1/2 times 7.5 squared over 9.8.
Oh, I forgot. Yeah, but I would do it calculator.
What did you get?
For me, I got the same thing.
Okay.
You wondering how to put it in that
How do
calculator?
you
I don't know how
how
to
do
put
you
it in
get the
that
fraction bar?
Is there a fraction bar?
You could put it in as 0.5.
That's what I did, but I got 200.
You guys got the same answers? Awesome. Okay. So now that we have this, we know this is our initial height. Can we plug it into this one's conservation of energy?
Yeah.
You guys don't seem very confident.
Yeah.
I'm sorry, I learned.
Because then you find.
Well, let's see, okay? We're gonna rewrite the conservation of energy, but we're gonna write it specifically for this case now, okay? Okay, is this 0?
No.
Is this?
No.
Wait, what's your question?
Now
This is the conservation of energy equation.
But I mean, are we still using the
It's
first
not
set?
zero.
No, because we already did this with the first set.
That's not zero.
It's not zero.
Okay.
This whole thing is solving one thing, you guys. It's multi-step. So, is this 0? Is this?
No.
Is this?
Yeah.
Is this?
No.
No, okay. Now, what are we trying to find?
Final velocity.
Okay. How do you suggest we go about rearranging the equation for that?
Multiply by 2.
Yeah, get rid of all the m's. That sounds good to me. Then what?
Multiply by 2.
Multiply by 2, okay. So that would be 2gh naught plus v naught squared equals vf squared.
Wait, how do you get rid of all of them?
Because since there's an m in all of these, that means that, like, if I were to take this m out over here, okay, if I were to take it out like that, right, and then I divide it by m, just go away. So anytime it's in all of the terms, you can take it out. It has to be in every single term, though. What's your question?
Where does the, so for the other side, I didn't see it, but, where happened to the other 1/2?
1/2 and 1/2, it can't.
Because if you do 2 times 1/2, it becomes 1.
Oh, so, gotcha.
Yeah, sorry, we did that a little while ago, and you guys told me you got it, and I didn't have to,
Oh, no, I
like,
just
show that
wasn't
stuff,
watching
so I'm
them.
sorry. Okay, what do you do now?
Take the square root.
Okay, I think I got it.
Okay, so what is our final velocity?
7.55.
I don't know. Do you guys agree with her?
I don't know.
I got 7.65.
As you give me an answer, I'm going to write it on the board. We've got 7.55 and 7.65.
I got 7.6. Okay, so I'm probably.
Oh, gosh.
It's probably a round.
It probably is just a rounding difference.
I'm about to do it.
Although everybody should be using the same value for
I
H
got
naught, G, and V naught.
7.65.
7.6.
7.65. Maybe they didn't square the 1.5.
So is that more than, less than, or equal to 9?
Less.
Less than 9.
Wow, we did it.
All right, do you guys have any questions?
Nope.